I realized I was losing my voice not talking. Hey, I'm Patrick. I'll be the first talk tonight that doesn't have something coming from Facebook. We should thank them. They do a lot of good stuff on the tech side. Hi. This talk doesn't really have a good title, so I'm just skipping past it. This is actually not a talk about Fargate. It's not a talk about Terraform. I'm going to use both those things. It's a talk about an opinion I have where GUIs kind of suck for designing infrastructure, and you should probably look at coding it. Who am I? I'm Patrick. Right now I manage a team at a company called Lixar. Our team's about 25 people. Lixar is about 200, but we write stuff for other people. My client's an airline in the States. Kind of neat, get to see behind the scenes of an airline. Massive scale, like an AWS account that probably is like, I don't know, a month or something crazy, like huge scale of stuff. And it's neat, I joined the company at a time where I got to see the very tail end, thank God, of a migration from on-prem to AWS, and got to go in as a contractor and say all the things. I was at Manifold. Before that I was at a bunch of other places, and one of the things I got to play with a lot at Manifold and previous was just this concept of learning to code your infra. I had my own startup at one point. It was kind of like, oh, this has to go live somewhere. Well, AWS gave me some credits. Let's figure that shit out. And then was surrounded by a community like this of people like, there's at least a dozen people in this room, at least, who influenced my learnings on how to actually do that right and how to play with it. So I'm going to share a little bit. And then quite selfishly, when I was thinking on that, so let's figure it out. So I know Ian said no questions till the end. There will be a spot where I'm going to break that rule because it's the last talk and I want to get things going. So disclaimer, not a talk about Fargate, but hey, as I learned in Halifax's channel the other day, there's a lot of people who actually use this thing. I don't actually use it in prod. I started playing with it for the talk. So we'll defer to them on some detailed questions. But just very quickly, from what I play with, it just abstracts away like the whole Kubernetes side of things. You don't even know what it is behind the scenes. It's actually it's an AWS service. It's actually a launcher, technically, of projector. Don't do that. Press the power button. What? To turn off. Any other button. Any other button. Not the power button. I really want to hit the power button. I'm hitting every button. There we go. Phew. I mean, we could just go to the bar. So it's kind of neat. There's all these things like, so the world has moved to containers. If you're not packaging your things up as containers, you're left behind. But then you're left with this really fun problem of how do I actually get my container to run in the real world, whether that's a dev environment, a sandbox environment, staging. You know, I work for a large corp now, so like UAT, there's all these environments you have to go through. You know, how do I actually get that thing going? And the answer usually is talk to a DevOps team or an ops team who is certified in Kubernetes wizardry, and they will take it from you and they'll gladly put it wherever you told them to put it, and they'll make it happen for you, which kind of defeats the purpose of learning DevOps and all that, bridging the gaps. So there's all these products coming out there, all the way from like the Ranchers, the OpenShifts, the orchestration tools on how to like just go pay attention to a repo, put the container in, to something like Fargate, which was actually quite impressive when I play with it, which simplifies it and abstracts it away even more from you. So it basically takes, these are the things it takes away from you ever having to care about really anything to do with Kubernetes, because it really isn't actually Kubernetes. It might be, who knows. You EC2, so if you don't play with AWS, that's like your raw compute. That's, if you used to have a server in your closet, AWS has an EC2 instance, and there's different sizes. And you can directly build it connected to your pipe, which is kind of cool. So yeah, that's what Fargate is in a nutshell. I have some slides in here, like for those, anybody who knows anything about Kubernetes besides for like, it's a thing. Cool, awesome. So some mappings of some words. This was the first thing I was trying to figure out, like, There's a lot of AWS lingo involved with Fargate. What the hell do they actually mean? You could think of a task like a pod, and then everything else is just word changing. Obviously, the technology is different, but it's kind of laid out all the same, oddly. Maybe it is Kubernetes. I don't know. But yeah, and then when you kind of go up, there's another slide I can bring up later when you go up a layer and look at the control planes and all that stuff. But again, this isn't a talk on Kubernetes, nor is it a talk on Fargate. Why would you ever want this? Maybe you have a very simple thing that you've wrapped up as a container and you quite literally just want it to exist in the real world. You don't care or need to know about network throughput or how big the EC2 instance should be. A T2, should it be an M3, should it be like one of the other XL, whatever AWS has come up with. You don't care about any of that stuff. You just want it to exist in the real world. You want it to scale up when it needs more of it, and you want it to scale down when you want less of it. You want it to have health checks. You want it so that like, oh, I have it now tailing my container registry, so I just put up a new version of it. Cool, it's gonna auto launch this thing. That's a little scary. I don't want it to actually do that if I broke it by mistake. It has that all kind of built in for free. These are, if you've ever managed a Kubernetes cluster, if you've used any of like these kind of cloud container orchestrations, these are things that you control and configure easily with all those products, but you need to actually know how to write the YAML for it, or whatever the command line interface. This stuff all just kind of typically of AWS just wraps it, hides it, comes for free. And you are supposed to think of it as a launching mechanism. Like it launches stuff. It's not really the service itself. So those are reasons for it. There are probably a lot of reasons against it. Like all of that stuff is extracted away from you. You don't know what the EC2 instance is behind the scenes. It's a hot pool behind the scenes. Which means you could be landing in, just to pick on something like a T2 instance, which is a tiny, free, nice little instance, has a virtual CPU load. If you know AWS at all, it has really shitty network throughput on it. So if speed is a thing you care about, Fargate's probably not your thing for you because, well, it might not be. It might not end up being in the cluster or the size you want it. Of course, there's nice hacks because you get to define how much memory and CPU your thing needs. You can manipulate that to guarantee it ends up in a certain bracket. Billing is a little expensive too. There's a cost for this abstraction over the EC2, but much like Lambda, it is serverless. So you're not paying for that compute when it doesn't need to happen. So if you had a cron job type container, something that needed to run periodically, a bunch of email marketing things off databases behind the scenes, Fargate's actually a really good place to launch it because you'll only pay for it when it exists. It'll shut down, come back when you need it. So things like that actually are a really good place for it. But this talk is actually about GUIs and how I don't like them. So next slide over, we're actually going to go look at the GUI. Much like the first talker who said other people do things really well and we just steal it, like AWS has a really nice GUI, so I'm going to go play with it. It's not actually nice. But I in learning this, I've put into the slides. We'll share this somehow afterwards. I guess I could put out a tweet. Don't do that often. Yeah, I just followed a blog that showed me how to do this, but then you go and play with it. So let me go. I think I have, let's see. Oh, direct linked work. All right, awesome. So anybody never looked at an AWS console before? Yeah, awesome. They're like, hey, like that, stay that way. Don't. For those of you like me, who've been here for quite a while, yeah, like just to give you an idea, like good luck figuring out what service you want. Luckily, if you do, like, I don't see Fargate listed anywhere, but if I just type it in, it's at least smart enough, not to tell me that Fargate's in there, but at least the search somehow came up with it. So I'm just gonna get rid of this. Get rid of that search, go away. Oh, I can't, fantastic. I'll just reload. All right, so they have nice little wizards. So I am actually gonna do this now. This is my own private account. I will rack up a small credit card fee doing this, but I do it for you guys and you, because I like you. So I'm just gonna do Nginx because that's easiest. So one of my things about these GUIs is they're actually not that evil. They're probably a good way to start. If you wanna learn like what the terms actually are, and what they can actually do, fine, the GUI is good, but you have to remember it's intentionally abstracting away a lot of the complicated stuff behind the scenes. So you're going to skip over a lot of the fundamentals, which I'll roll back in a couple of minutes. I'm not actually paying attention to time. I hope someone does. All right. What's like my end time?
Like 8:50.
All right, cool. So I'm going to go ahead. So here, like, again, this is a launching of a container thing. So this is just a WYSIWYG. I could go in here, hook up to, like, let's assume I've got containers sitting somewhere in a container registry. Obviously, it's much easier if it's sitting inside Amazon's container registry, but you can hook up Docker Hub or whatever. And I could go pull it directly out of there. They've just, you know, got the open source ones here ready for me to go. So I'm going to do Nginx. There's things down here. Again, task definition is the pod from a container world. So in this little simple thing, I'm not bringing multiple containers together to perform a single thing. I'm just picking on one. But I could do that if I wanted to. It's abstracting away stuff for me already, but hinting at the fact that it's doing things like there's some sort of weird network mode going on. Don't know what that is. Compatibility sets Fargate's requirement. But you can see here kind of the two big things from a task is memory and CPU allocation, which makes sense. You got to say how much memory the thing's probably going to need and how much CPU it's going to need. These are like, there are lots of like Reddit posts that will tell you what to set these at if you want to like take a stab at what kind of EC2 instance is going to end up showing up in, which is nice. But yeah, they abstract that away. The intent is you're not supposed to care about that stuff because you just want your thing to be up on the internet. And I do find their pictures kind of help you figure out where in the process you are. So we figured out our container, we told it memory, we defined our task, that's their pod, that's the thing that's going to be up. And then we have to actually say the service. This is where you could get more interesting and say this is like a cron job type service or a continued, like something that stays up all the time. And here's some more abstraction away that I'll pick on a little bit later. How many of them to have running? I'm just going to say one. I'm not going to go customize any of this. Security groups. If you don't know anything about security groups, that's like probably your number one thing to go read tomorrow is all about security groups, because they're incredibly powerful and very useful, and you shouldn't just auto accept anything. But yeah, I'll make a new one to throw this stuff into, and I am actually going to put it behind a load balancer because I like to. That way your public-facing IP address doesn't change every time you redeploy as well. Because it'll be sitting behind a load balancer. So I'll do that, and boom, cluster, well, let's call it late night clustering, and some other magic stuff. Okay, there we go. Yeah, create. So it does a lot of stuff for us. This is kind of nice. It's going off, it's making things. These are things I could go Google, I guess, while it's doing it. Super excited because when it's done, I'm gonna have an Nginx container up. Like, this is exciting. I'm gonna be able to hit a URL, it's gonna be up. I have no idea how any of the security works or the access control or how to change that container ever. But it's kind of nice. Like, it does all these things for us, and it will keep going and going. And instantly I'm racking up a bill, by the way. This is not free. It's not that expensive. I think I did this yesterday and I left it on for the day. It cost me like 15 cents. But like subnets are being made. So that's from like an auto scaling perspective and redundancy and all those right things for cloud. For AWS, there's different places you can put things in different regions. You put them in different subnets, blah, blah, blah. Yeah, so last thing to come up is a load balancer, which will get attached to a task group, which is somewhere up here. And that task group has a healthy node in it, hopefully, which has Nginx. We need the VPC to exist. That's the last couple things. Oh yeah, and the built-in logging for me too. So yeah, this will work, I promise. AWS never fails. So what I am gonna show when this is done is two things. So you get it, like, this is cool. This is fun to play with. What do we think if this was our, let's not even go to prod. This is just our, like, we're pre-production startup. We just need our things to show up so we can start showing them off to our investors or what have you. What's one thing you think you might, as a development team, decide you just did wrong and need to change? Of all those configs you saw me go through really quickly, what's one thing you think you might have to change? Node count. You might need more of them. Yeah. Memory, maybe you got it completely wrong. That, like, if I had like diminished that number to a super small thing, this would actually never come up because the health check would fail. Okay, cool. How do I change that? Might probably go back into there somewhere in this configuration. It's taking forever today, of course. Let me go back. Let me go look. So we go to ECS. That's the services we're in. I'm going to look at the cluster, late night clustering. So here you get a nice high level of stuff. Nothing's up and running yet because it's still not done, but I can go look at it. And I could probably see the tasks. No, it's not there yet. It'll start coming at some point. There'll be a task listed. And I'd go change it. I'd go edit the change. I'd go commit it via the GUI and done. What if next week comes along and we decide that was wrong? I have no audit trail. Like, this is the first thing that comes completely out of these GUIs is you have no audit trail. Even a Google Doc has a better audit trail than this thing does. So if you have a bigger team, maybe there's 3 of you and you're all trying to figure out how to do this, it's quite obvious it's going to fall on itself. And I'm guessing, show of hands, most people here know how to use Git, push code into Git. Yeah, wouldn't it be nice if we could commit this somehow? That's where codifying your infrastructure comes in. So yeah, the GUI gets you a lot of places, gets you things working, but you get no history. You get no Git blame. You can't blame me for fucking up your infrastructure because I could just do it by mistake, not know what I did, and just completely mess it up. Not that I've ever done. Where's Yeoman? No, I've never done that before. So I'm actually really curious if it's, oh, there, it's starting to come live. Takes forever. The other fun thing is, I'll go back to this later if I have time. Deleting this is almost impossible because I don't actually know everything it built. There is a really fun button here that lies. I'll show this when it comes up later. If I go delete this, it took me like, I had to go read more stuff because of course the interdependency between all the things it just turned on in what order. When it goes to delete it, for some odd reason, AWS itself doesn't know the order in which it has to delete things. So like some expensive things get left on and you have to go figure out how to kill those. Yeah, kind of not what you like. So what's the alternative? Let's go back to this. Happy little land.
I've got a 75-cent piece of infrastructure I had like 3 years. I still can't find it.
Yeah. It's like, I think you, what did you just use? Change your credit card. I think that's your style. Yeah, just cancel that credit card.
Change identities.
I may have something at Manifold still going. So what did we make? A bunch of stuff. There is a nice listing. You can find out more details. I am bashing on it. It is actually nice. This is how I learned to do AWS stuff. I went and played with the GUI. But you start learning really quickly. This is not how you, I don't know, this is like coding directly on your server from a developer's perspective. Like, this is maybe really hacky, nice feedback loop really quickly to learn, but not really a great way to go to like enterprise production anything. It did do a bunch of components. It did a load balancer. It created a virtual private cluster. I always forget to see, but a VPC, added a public IP address. Didn't do the DNS component. That's cool. It did a launch type. It did a task. It did lots of little things. So yeah, that's a lot. That's a lot of things to think of. Like, if I didn't have this GUI and I wanted Fargate, that's a huge barrier to entry. Like, that's a big blog post to go read. I read it. It's very big. You get lost halfway. So I already did that. Actually, I'm curious. Does anybody actually use Fargate that's in the room? There was chatter the other day. Okay, so they're the people to ask later. Really put your notes. I do, if we have time, I actually am curious, and I'll, if you follow us to the social event, or if not, I am like, I see a lot of use cases for this. I'm not sure if I have one today. But even from like a dev, like early pre-prod perspective, the idea of like just putting your stuff in a container, having a nice, easy way for it to show up somewhere that people can hit, I can see a lot of reasons for that. So yeah, the developer thing I already asked about. So yeah, where's the modern world? Some of you may have heard like the buzzy kind of like GitOps world. Like, we've got DevOps, now we've got GitOps. The idea is just coding. Like we all know what like Git flow, GitLab flow, GitHub flow, they all revolve around the concept of pull requests or merge requests, depending on what product you use. The idea of getting your peers to actually look at what you're about to do before you do it. Pull requests. Well, can't do that in a GUI. You'll see the trend here. Be really nice if out of that we could actually see versions of what we're about to do as a demo or as a test. We could run tests against it, see if it's actually what we want to have happen, what we coded versus what we actually see at the end. Like the whole go live immediately kind of thing is nice. So we can do this with infrastructure. Codifying your infrastructure is not a new thing. I was a sysadmin at one point in my life, way back before any of this ever existed. And you know, it existed even before some of these things. Like I still am, I think, just a really good bash scripter. It's really my forte in life. I write some really complicated bash scripts because that's how you started when you were a sysadmin and you had that server and you wanted to do things over and over again. You didn't write the command in over and over again, you bash scripted it. And then, you know, things got really nice. Somebody invented these things like Puppet and Chef and Ansible. Ansible is basically just SSHing into a box and running a bash script for you. Still cool. You can version control of things. Puppet and Chef are more dealing with how the compute set is set up and what like packages and libraries are actually in it, less so than the software that you're trying to run in it. But they all have a nice happy place. And that's how I got started. And then someone like told me about code repositories. Back then it was SVN, Mercurial, all these things. And the idea of actually tagging stuff. So version 1 of my Fargate deployment is this. Oh crap, it's not exactly what I want. Version 2 is that. So infrastructure code is kind of a no-brainer from a developer's perspective. But if you flip your hat from like the history of who takes care of these things from an infrastructure perspective, it's a different perspective. You got to go from like bash scripting all the way up and build up and build up and understand that codifying your infra can be super, super powerful. Yeah, of course, there's like an acronym, IAC, Infra as code. Some like big things, I've already said these. Scaling, no longer need to do the same thing over and over and over again. You can just rinse, repeat your code. It's kind of nice. Accountability, I mean, I love that Git calls it Git blame. Like in a blameless Scrum environment, the most useful tool is Git blame, not Git empathy. I don't know what else you would call it. But like, you know, you could see who changed that memory line from 512 down to 256 and fucked everything. Or, you know, change the database's password. Well, that shouldn't be in code, but anyway. You can also, and I love this, and I got kind of married to this a while ago, the idea that you're, you know, as we saw with the React stuff, like you have package.json, you have dependencies. One of your dependencies has version numbers on it. I love the concept of having a version of your infra be a dependency of the software release. Saying my new thing that's coming out actually requires version 2 of my infra to go out. Or vice versa. You could say infra number 2 actually needs the software to be upgraded for some odd reason. And where I am right now, we do a lot of these kind of things where, because they just did this huge lift and shift to the cloud, there's a lot of now taking the code and actually making it more cloud native-ish. And a lot of infrastructure changes have to happen during a release, and decoupling that, being able to show the dependencies is hugely important. So actually being able to version your infra is kind of nice. So Terraform is probably, and maybe people younger than this gray bearded guy know of the newest, latest, greatest version of Terraform, but I really like Terraform. In fact, for this talk, one of the reasons I wanted to do it got me back into a little bit, and I got to look at the newer version of Terraform, which solved a lot of the hacky stuff I have to do like a year ago. It's kind of a weird programming language. I forget what it's actually called, the language. No, not, yeah, anyways. H something, yeah. It's easy to read, but it has some weird little uniquenesses to it. But the idea is it's cloud agnostic. There are other things out there from each cloud provider that wrap their CLIs, that let you do a bunch of stuff via code to their cloud, but they're not cloud agnostic. You kind of commit to the Azure one or the GCP one or the AWS one. Terraform is cloud agnostic. It's providers. There's these ideas of a provider And anybody can be a provider. You can write stuff. Manifold, I think, has a provider Terraform thing. Other people do as well. So you can do AWS. You could use AWS for something. You could use simple DNS for your DNS. You could use Let's Encrypt for your SSL certs, all in one code base. It doesn't really care. You just have to import, like, put the right credentials in and talk to them that way. Very, very powerful just because of that reason. Variables and all that kind of stuff that you get for free with the programming language come with it. So I'm going to skip this one because it's boring, and I'm going to go to the real one. Terraforming Fargate. That's just I should have just made that the title. So those same building blocks we saw that GUI do, we're going to do in Terraform. I am not going to live code in front of you. I am going to show you real code. I just forked someone else's repo that has this demo. And I got to say that, like, you know, when you talk about the WYSIWYG, the GUI, sorry, just hiding all this stuff and making the barred entry really quick. The nice thing with Terraform is, like React, there's a big community behind it, and the providers themselves are incentivized to be behind it. So there's tons and tons of fully legitimate production-ready repos out there that you can just fork, modify, go, and be successful with. So you get kind of that same out-of-the-box fun without having to do much. So I should go back to that GUI. I'll go cancel everything later. Am I in the right? I want to go to this one. PW. All right. Yeah, maybe I'll show you the code first. So let's go into the So generally speaking, Terraform is broken out into all these TF files. There's main kind of, there should be a main, well, there doesn't have to be a main TF, but normally you would see one. Anyway, first thing, variables. I never saw any variables in that GUI. Like the hard code stuff. I don't like doing that. Variables lets you actually define and output things. So you don't really, if let's say your container needed to be passed a variable that was the database's URL, username, and password. You don't need to know that if you're using you don't need to know what those values are if you're using Terraform. You could plug in HashiCorp's Vault. You could go get that stuff, the username and password out of Vault. You could get the URL or the name, the IP address, depending on how you set it up, for the database from AWS directly as a variable and just connect the dots, which gets really fun because you could actually generate that password in Terraform with a random string generator, push it into Vault, and never actually see the thing. Little things like that get kind of interesting as you become a power user. But the idea is variables. So there's a bunch of things like AWS region is set in here. I've given it a name, availability zone count 2. This is the container we're going to use, port expose, the health check pass, and that same CPU and memory that you saw in the GUI. Main components, you know, it's nice. You can, there's no real hard fast rules with Terraform code on how you break things up. I really like this demo because they actually broke it up into kind of the sequence of things that are important. So that GUI had all those little circles going off in checklists. It's kind of matching this. So the main components being the networking layer. So we have to set up our VPC. There's some nice functions that you can now leverage to do your CIDR block, set up your subnets. So the only thing we really hard code in here is kind of what the internal IP range needs to be. Everything else gets figured out for us. This is a lot of code. Like, that's why I'm not live coding it. But I just forked this repo and it did everything for me, and it came from AWS. So like, this isn't magic. It's start here, modify it as you want. So this is the networking side. Then we get into the container side. So just to kind of show you the meat of it, this is setting up through a template file. I'm not going to get into that, but this is basically setting up that container, the task definition. What container to use, how much memory, what port to expose. If you think of it from a Docker perspective, that's all we're really setting up in this chunk. The rest is setting up the service around that task. We're saying, oh yeah, use the one I just set up here, put it inside the cluster I made earlier. I'm giving it a name, but you notice I'm not passing around the cluster's name as a hard-coded string. I'm just passing it around as a variable. It's all just being passed around and extracted from the other components, which means I don't need to know as much, which is kind of nice. And there's my load balancer. and some other stuff, logging, auto scaling. Yeah, just pulling it all in. So lots to unpack there. It's near the end of a very long night. So we're going to end it with me creating yet another cluster and just racking up more of a bill for you all. Let's go here. The things that should sell you on Terraform is what I'm about to do. This will just blow your mind. I'm going to type in the word Terraform and I type in the word plan. Like, what a novel idea. I'm going to see what I'm going to generate without generating it. This is crazy. What you're missing at the very beginning of here is a very nice thing that Terraform does for you. Yeah, there's a lot of stuff. This is like the exact same thing the other guy did in the GUI. There. Let's see. State. Terraform has this concept of state. It has a state file. There's fun things where you can put it up in like an S3 bucket and encrypt and all this stuff. But it keeps track of the state. So it's known, like the last state of you doing a Terraform apply, that's the next command, gets documented in the state. This is all those variables get extracted into actual strings, whatever they end up being. When you go to do your next Terraform plan, it actually checks AWS, checks the state, and says, uh-oh, there's something different here. Do you want to, and you can do an apply to put it back to where you want. You can import the state. You can tell it to ignore certain things. You can see the delta between what you have and what you want. So I'm just going to go ahead and do this little guy. There's also a nice one. I'll flip this in. You can do a graph here through like dot notation. So you can see all the interdependencies of everything you just made, which is useful if you have a problem. Like sometimes you have cyclical dependencies that you have to deal with. You know, AWS or Terraform won't actually know how to make the thing because you said, well, to put the database up, I need a VPC. To put the VPC up, I need a database. That's a stupid example, but it can get into these cycles. By seeing it as a graph, you can see those cycles. So I'm going to do a Terraform apply. It does the same thing again. It does a state check for me. I could have like forced it just to skip this. Do I actually want to do? So just to read through this really quickly, I'll just pick the last one. Just like you were looking at like a diff and git or like a merge conflict or something, the pluses just mean these are things it's creating. And it's showing you the variables it will know on before, and these are things that will be known after when things actually get generated. So I'm going to say yes, because why not? And it'll go and do stuff. And this is a little bit of time. This is like why I still like my XKCD t-shirt that's like the compute, like, we're playing with lightsabers because our thing's off computing. I just need to change it for Terraform apply. Because this can take a while. But we're watching it actually get generated. So subnets got generated. It's doing all the network layer first. So that's a nice thing. Terraform kind of figures out the layering of what has to happen first for other things to happen. Word of like caution, if you do a database generation that's fairly large, it can time out on you because databases just physically take a while to turn on, or actually have to take a while to turn on. And if I go back to our nice little GUI, here, let's take a look at our clusters. Am I in the right zone? Yeah. Okay, so here's the one I'm making right now. Still no idea what's going on with this one. It's funny how the GUI failed, but maybe my Terraform won't. Or I've run out of money. Who knows? I'll go look at logs later. So if I go back to my clusters, things are slowly turning on. There's no task yet. Tasks are being, if I go look at my task definitions, this is the one that just got created by Terraform. I've made a few of these in practice. They're not here anymore, but that's why the incremental counter is there. And you can see there's the image, the container image is going to pull down. That's everything I set in my configuration. Going. Let's go back and look at terminal. Still going. And at some point, while people maybe ask questions, because I think I'm out of time. Yeah. All right, we're gonna let this guy, this little nice AW, it's the load balancer that always takes a while. Anybody have any questions?
So, for example, like if you want to just update one of your microservices, like from one version.
Yeah. So this gets done in time. So I'm going to go to my code, and let's just, for the sake of simplicity, go in here and say, so where did I pull my container in? Right here. So with containers, like pretend there's a new tag or latest. I changed that one variable. So I think, do I still have it? Let's see, can I do, let's see if my version control still has it now. Hold on, give me a second. There is Nginx demo, text only. Oops. I just want another simple version of it, so I don't have to, there it is. I think in the docs they say which one it is. Yeah, there. I'm gonna pull down a different tagged container. So, okay, cool. Hey, it's done. Let's go look at it. Please work. Okay, so let's just go look while it's doing things. Clusters, there it is. Demo cluster actually did something. Yay. It has a service up and running. Because I'm overkilling it, I did 3 of them. So there's 3 of these containers running. The service name is demo app, blah, blah, blah. Interesting that it's not actually doing anything. Let's go check. So ALB, I think, sits under the EC2 stuff. Load balancers. So I'm just going to go look at the load balancer, make sure I didn't mess up my config. So there's the load balancer. It's listening in on port 80. Cool. Oh, that's why. Good old Chrome wants me to be more secure than I am. There. Hey, look. Woo! That's the container I loaded. So to answer your question, let's pretend that's a new version of something. If I save my file, save it, I go do, just to show you, git diff, no smoke and mirrors. Oh, there's my difference. If I do Terraform, I'm going to do a plan because I'm safe. It's checking state. It's going to tell me what it's going to do for me.
It will automatically, like, remove one of the container from the balancer, then it's going to be one, like, so it's like if you have 2, like try to clear out.
Yes, so that's Fargate that's doing that for you. The Fargate with how you set up by default, it does a lot of that magic for you. You'll see it in a second. So just to show you what it's saying is you're changing the name of the container, which means you need a new task definition, which means your service has to be updated. So the delta here is this needs to change. This is the old one, this is the new one. That's really nice. You could put that into your CI/CD your CI pipeline for a pull request. Go run Terraform plan. Do something smart about your AWS credentials so it can do it. Show me the plan. If there's a delta there, like have someone actually sign off of it. There's lots of ways to approach it, but that in itself is kind of nice. Some things will change. And then I'm going to add something. That's a new task. I'm going to change one thing. That's the task definition. Yeah, task definition. Let me see if I'm reading this. Yep. And I'm going to destroy the old task definition. So I'm just going to apply this and let it go while I keep talking. So yeah, what we'll actually see is there's a max how many running tasks can exist at one time. So it'll turn on the new 3 because I have it set to 3. It'll turn on the new 3, make sure their health checks pass, and then it'll start draining the old ones. And you can control that at a pretty nice detail. So yeah. So when I go back to that cluster, it's going to do a couple things first. So this is kind of the fun start about Terraform, fun plus minus. It tells me it's done because technically it's done. It doesn't care that Fargate has to go do work now. But it's like, I told Fargate everything, bye. So yeah, I don't actually have a feedback loop on when it's live. There are modules I could probably leverage in this code or add to Terraform to actually do some checks before it says it's done. But just in this example, it's not. So if I go back to here, let's go look at the load balancer, blah, blah, blah. I want to look at listeners. Yeah. Where do I see it best? Let's go into task groups. So if I go back to ECS, you'll see, okay, so I have my service is still up and running. Cool. Still up there. You'll see that the running count's going a little high. It used to be at 3. That's the new ones coming online. So if I go look at this group and I go look at tasks, you'll notice there's a 9 and there's an 8. We missed the event because this was a pretty simple case. We missed the event where these would have been coming up but not active. As soon as they pass their health check, they go into running. The health check is configured in that Terraform, but it was just checking port 80 to make sure it comes back with something. You could be more specific there, like not just tell me something's there, but a specific string or what have you. It's a microservice backend. You can have them have health check endpoints. And then it's burning down the old ones. So I probably yacked too long to do this kind of fun part. This code shows you the IP address of the container it's on. Yeah, so you'll see I'm just refreshing. Some of the old ones are still going to be there for a little bit. Now I've lost them. That was like one left one. If I do this actively while the demo's going, you see it kind of float and then come back. So you can see there's 3 containers that have 3 different internal IP addresses, and that's the text version. So that is the demo. I think that's really all I had. Yeah, there's the stuff. Thank you. Go forth. Code your infra. Never turn back. Summary. GUIs are pretty good to learn. A little expensive because you have to like go figure out how to turn things off afterwards. And it's not just AWS. Like I was learning Google Cloud for a while. Same problem. Now I'm learning Azure. Same problem. You go do everything through the GUI. You don't really know what it's done. I now prefer learning through pulling down the sample provider Terraform code bases and doing it that way because I know Terraform will always tear it down or at least be explicit with what it did, and I can go hunt it down if something fails. Yeah, and Fargate seems cool. I'll try to find a use case for it, but yeah. Awesome. Thank you.